This will be an updated practice final exam for Math 1107. And what we're looking for here is the kinds of examples you should expect and the strategy to get the answer. Now remember, the protocol for this is to look at it carefully, read it, and before I go over the answer, you give it a shot. So you're going to pause frequently. All right, let's take a look at this one. The total amount of money in an account with this many dollars. This is the principal investment, and they're giving you the formula. So here it's a matter of substitution. So 1690 plus, now I would put this in parentheses because this is all in a sense one term, 1690 times, now the rate you need to convert from its percentage form to its decimal form, which is 0.05 times, and then the time in years, 24 months would be 2 years. So there's what you want to put in your calculator just like this and see what you get. And the answer comes out nice and even, 1859. Another example, read and see what you come up with. The product of 11, y, and x. Well, the key word here is product. That indicates multiplication. Now, if they had put the word sum there, that would be something different. So what would you get for this one? Well, this answer's here, 11xy. Now, if it were the sum, it would be 11 plus x plus y. Again, we're giving you background of kinds of things you would expect on your final exam. Now, here, we're looking to see if this statement is true or false. So the absolute value of 15 is 15. Is that less than or equal to 15? We had said with this inequality sign, if part of it is true, then it's true. So part of this is true. 15 equals 15. So this is true. Now here we see a division, in a sense, in the form of a quotient, fraction. Negative divided by negative is going to give you a positive, and we don't write the positive. And 3 goes into 48 16 times. So without the positive sign, that would be the answer. Now, this example is working with fractions, and they have different denominators. So we need a common denominator between a 4, a 2, and an 8. Hopefully you can see that it's an 8. Now we can multiply each of these fractions by 1 so that the denominator becomes 8. Well, here this one is 8, so we can just put that there. But this one is not. What form of 1 would I multiply 1/2 by to make the denominator an 8? And the answer is 4 over 4. That will make our denominator 8, and now our numerator a 4. And what form of 1 would I use here? 2 over 2. Our denominator now becomes 8, and our numerator a 2. So now just adding up the numerators, we get 7 over 8. Now, in this example, you want to be careful. There is a protocol. Please excuse my dear Aunt Sally. So we do parentheses and exponents first. Let's write it again. 2 times 4 minus, now what's inside the parenthesis gives us an 8 that we're going to square. So now we could, again, you can wiggle this a little bit. 2 times 4 will be 8. Now, 8 squared is 64. So 8 minus 64 is actually a negative 56. This was an incorrect response. In this example, we're just combining like terms, remembering when there is no numerical coefficient in front of a variable, there is a 1 there that we can put in there for calculations. So 9x, 1 more 10x, 3 more 13x, plus 5 and 2 is 7. So again, knowing the protocol and checking your work. Remembering you want to pause, copy the example down, work it on your own, and then check the protocol. Now there are a number of ways to do this. One suggestion, take this negative, bring it over to this side as 9y. Just transposing changes the sign of a term. You want to try to keep your variable. Bringing this positive 8 over to this side makes it a negative 8. So this will give you negative 18. Then you're just going to divide by the numerical coefficient. And that gives you x equals negative 2. Now in a case like this, if you did it the other way, you need to be very careful of the signs. Now for this one, could do it a couple of ways. One way is you write it out. Now I'm going to take this term, move it to the other side where it becomes a positive 11 tenths. Taking it from one side to the other. Now I could multiply everything by 10. That would cancel out all my fractions here and make our denominators a 1. That would be a good way to go. Or since you have this 7/5 y, since these are common denominators, this just becomes 22 tenths, adding our numerators over our common denominator. Now we can use that other technique too of a term that we use to multiply something, a fraction, to make it a 1. You may recall that's the reciprocal. So if you take the reciprocal of this, which is 5/7, and you multiply both sides by 5/7, here these all cancel out, and you're just left with a 1y. And here we can do some canceling out also. 5 goes into 5 once, 5 goes into 10 twice, 2 goes into 2 once, 2 goes into 22 11 times. So you end up now with the improper fraction 11/7, which is, if you can see it there, the actual answer. Let me erase it so you can see it. 11/7. That was one way to do it. Now let's do it the other way too. So we're going to multiply everything by the least common denominator, which is 10 here. So 5 will go into 5 once. This will be 2. 2 times 7 is 14y. 10 just cancels out here. This becomes an 11. 10 cancels out here, and this becomes 11. And now we transpose the 11s to the other side. That'll give us a 22. 14y. Divide both sides by 14. We now get y equals, and then simplifying this, we can take a 2 out of each. This would be 11/7. So 2 ways to do it, and hopefully you are familiar with both. Let's go on. Pause, write the formula on your paper, and you want to solve for p. So we know that we can divide out the things we don't want, RT on this side, RT on this side. So now we're left with P equals capital I over RT, which is what we have here. So they gave us sort of an easy one here. For this example, you're going to read it carefully. Write an equation, and then check it out. All right, 64 is added to a number. So we have x plus 64. The result, which is an equal sign, is 44 less than 3 times the number. And that should be your initial equation. Now you're going to subtract an x from both sides, or transpose this, becomes a negative x. So you're left with a 2x on this side. Going to transpose or add 44 to both sides. This gives you 108. Divide both sides by 2. X is 54. So again, the challenge was to get the correct equation, then follow the protocol to solve. Write the example out and solve. So we're going to transpose the positive 5 to this side, where it becomes a negative 5, and 11 gives us a 6. So 3z is greater than 6. So now we divide both sides by 3. And since we're dividing by a positive, we don't have to change the direction of our inequality sign. So we then get c is greater than 2. Now that would be the algebraic notation. They want our answer in interval notation. And then later they're going to ask us to graph this too. So I suggest you graph it first. what sign will you put at this point of 2? A parenthesis or a bracket? A parenthesis, since 2 is not included. Will the parenthesis face right or face left? Well, it's greater than, so it'll face right. And where does it go to? It goes to positive infinity. And in our software, that's indicated by the ellipsis. So how do we put this then in interval notation? Well, we're going to start with a parenthesis, this one, put in the 2, comma, and then positive infinity, and infinity always has a parenthesis. Now notice you'll be picking out from the software the set of parentheses. Then you need to move the parentheses so you get this result when we are graphing this. But this is the interval notation for this inequality. And once again, there's our next slide. We have chosen the set of parentheses that goes up to the number line. We then grab and move it to a positive 2 and extend it to the positive infinity n. So the graph would look like this. Now, for this example, write the ordered pairs down. You want to find the slope. And reviewing that formula, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So you could fill it in, 5 minus 4 over 7 minus, now our x sub 1 is a negative 6, so minus a negative will make this a plus 6. This gives us a 1, and this gives us a 13, which is our slope. Now it would be undefined if our denominator ended up as 0, just to let you know. Now in this example, y equals something. I would put it in slope-intercept form. Y equals mx plus b. So this is going to be y equals a negative 2x plus 1. So now it's easy to pick out the slope, which is the coefficient of your x term, which is a negative 2. And your y-intercept, again, needs to be put as an ordered pair. Where x is 0, what is your y value? A 1. I've seen many students forget to put it as an ordered pair. Now, if you get an example where they give you this, then you would put it into slope-intercept form. Of course, you don't write the 0 when you're putting it into this form. So again, these are the kinds of questions and the material we've gone over this term as you prepare and study for your final exam. Now in step 2 of this example, they want you to graph it. So the protocol would be plot your y-intercept, which is a 1. What is your slope? It's a negative 2 over 1. So from that point of intersection, go 1 over and then up 2. And there's your second point. And of course, you'll need to be manipulating the dots to get them to look like this. Now, in this example, you may recognize the equation is in point-slope form. So they're asking you to find the point and to find the slope. Well, where the m is, there's a 2. So that is the slope. Now the key is when you are picking out the ordered pair, when it's in point slope form, you have to reverse the signs of what you see there. Because in that original formula the values are negative, the signs become reversed. So this is going to be a -4 for our x value and a -3 for our y value. Now in the next slide they're going to ask you to plot this. So I'll take this off. I find my eraser, there it is. And we'll go to the next slide. Now we need to graph it properly. First, graph this point, and I've put that there. Now, from this point, you need to plot the slope, which we said was a 2. So that will be, let me write that as well, a 2, in a sense, over 1. So from here, we're going to go over 1, up 2, and that's our next point. And it wouldn't hurt to write that ordered pair so you know where it goes. So that's going to be a -3, and then down 1, a -1. So let's go on and see that. Let's see, I have to. You'll notice now in the next diagram, the original point is not being listed, but that's where it is. And then over 1, up 2, you're putting in that second point. So take your time, check your work. Now on this practice test, they chose the skill of just picking out the ordered pair of where these two lines intersect. And it's right there. So what would that ordered pair be? Well, it's over 2, so it's 2. And it's down 3, -3. And if you wanted to check, you would put these values into these two equations, and it would solve it. But keep in mind, we could also, if we didn't know the point initially, go through the protocol, and I think I'll review that at this stage. So let's do substitution here. Y is going to equal, transpose that, and -4x plus 5. Now in this other equation here, I'm going to put in there 3x, that would be this 3x, minus 3. And now my value for y is this, minus 4x plus 5 equals 15, using one of the techniques we had earlier. So this is going to be 3x minus, a minus makes this a plus, 12x. Now a -3 times 5 is a -15 equals 15. So we bring this over. This becomes a positive on this side. So this is 30. Group our x terms. We get 15x equals 30. Divide both sides by 15. X equals 2. And there's our 2. And if we put our 2 into this equation, let's do it. negative 4 first, times 2 plus 5. This would be a negative 8 plus 5 gives us a negative 3. So we've checked it two ways, but in this case, all they wanted was to be able to pick out the point of intersection of these two lines. Pause, take a moment to read the question, and then what protocol would you follow? Well, it's just a matter of writing this out, 800 times. Now we can join the 1 and this decimal fraction. And our x value here is 12 months. So this is just a matter of putting this into your calculator and see if you get this answer. Round it to 2 decimal places. All right, let's go on. Now, here you need to be familiar with the compound interest formula. A equals P, Euler's E, RT. So do some substitution and see what you get. So this is 1325 Euler's E, caret, parenthesis, our rate is 7%, and our time is 21 years. Remember, this is multiplication up here. So just put that in your calculator and see if you get this answer. And pause. For this one, again, you want a protocol for doing it. You're going to substitute a negative 1 for the x term. So negative 1 squared. Again, you could put this in your calculator, should work for you. Negative 1 squared is a positive 1, so this becomes a 2. Minus 3 plus 5. So 7 minus 3 is 4. Now, the next one is very similar, so I will bring that up here. But now instead of a negative 1, we have a positive 1. So let's use our eraser and see what happens here. Now here, a positive 1 squared is still a positive 1. So this becomes a 2. But now 3 times a positive 1 is 3. 5 gives us a 10. But again, you want to have a clear, distinct way of doing it. And here's the protocol. Now, as you go over these, you should see you're getting a little bit of everything that we've done. Now, looking at this one, do you recognize what you see there? Yes, these were conjugates. Now, when you multiply or FOIL conjugates, you get the difference of perfect squares. Just have to do the the first and the last, and that would be 81 x squared minus 1, which is what we have. Now, to extend this review a little bit, suppose this were our original example and it had it equal to 0, what would be the protocol there? Well, factor it. In fact, let's just do that. And in its factored form, looks like so. Now what do you do? Well, each of the factors equal to 0 using the shortcut way. So then transpose the 1, negative 1, becomes 1. Divide by 9. So x equals a positive 1, 9. And then here x equals, transpose that, becomes a negative 1, 9. So again, they're not asking that here, but might be a question. Now here, again, a couple of questions could result as we see this example. But what are they asking? Just multiply and simplify. Okay. So we're going to distribute, and this becomes 45x squared plus 18x minus 25x minus 10. And now we combine like terms of our 2 in the middle, and we get this. Now, if they had given us this as the original example, and they wanted us to factor it, well, we could factor this by grouping. So what could we take out of our first two terms here? Well, can you see a 9x? And what are we left with? Well, 5x plus 2. And how about the second group? Well, we could take out a negative 5. And that would give us 5x plus 2. Oh, now we have common binomial factors, and we're asked to factor this, and that would factor into 9x minus 5, and our common binomial factor, 5x plus 2. Okay. Now, this example, if we're asked to FOIL, would become this, or use the method of multiplication, and then would result in this. So a couple of things could be asked here, but here all they're asking is multiply and simplify. Again, this is meant to be a review tape. Now here they are asked for us to solve this equation, and they want us to factor it. Okay, so we need to put it in standard form. 3x, transpose this, negative 9x squared plus 8x equals 0. Is there a common factor? Yes, we could take an x out of here, and we now get x squared minus 9x plus 8 equals 0. Now, this can be factored also, so we get x and our factors are 8 and 1 that we want to add up to our b term, which is a 9, but it's a negative 9, so both of these must be negative, so that we get a positive 8 when we FOIL it. And now we equal each of these factors to 0, and we get here x equals 0, here x equals 1, and here x equals 9. And they're asking us, 8. They're asking us to write each of the answers, separating them by commas in roster notation. The braces are already there, so it's just a matter of putting in our values. And don't put a comma after that 8. They'll count that wrong. All right, this is going to be a two-part question in which they're asking us to solve this quadratic equation. Now, it doesn't factor, so I'll use the whiteboard to work it for you. But as we look at this, it's in standard form. Our A value is positive, so we can just leave it like this. They're asking us to find our A, B, and C terms. Well, the A is 1, which we put there. Our B term is a 7, and our C term is a -7. Okay, I'm going to go to the whiteboard now to solve this using the quadratic formula. Now, in the next slide, they're going to give you the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So let's start filling in. B we said was 7, so negative b is -7 plus or minus the square root of -7 squared is, or b squared, 7 is squared, is 49, minus 4 in the formula. Put this in parentheses. A is 1. C is a -7. And that's all over 2 times 1 is 2. So we start to simplify. -7 plus or minus. Now this becomes a positive 28. So 49 plus 28 is 77 all over 2. Now our discriminant is positive, so that's going to give us 2 real number answers. So we got to write them separately, and we'll see that in the next slide here. Let's go on. I'm going to leave all that up there. Takes a moment. And we clicked on this button. 2 different real solutions once we found our discriminant was positive, and we're writing it separately. And there's the work to support your answer. Moving into our last unit there, looking at the question they're asking us. What does this say? A in union with B. So again, there were no braces, so we had to be sure to put our braces in there. And then we start listing the elements of our sets, separating them by commas and not repeating. So you include everything, but do not include repeats, and be sure to put in your braces. If you don't, they count that wrong. And don't put a comma after the last item. Okay, as we look at this now, this will be simple probability. So what's your sample space? Well, you're going to add these up, get 84. Now, what are you looking for? Randomly, students will have headphones. Well, you had 36. Now, you can take a 12 out of each of these. I figured this already. So this will give you 3 7ths, which is your probability. Now, let's review this. Was this empirical or classical? Well, this is empirical because we measured the number of students. We didn't figure it out mathematically and then are comparing it, which would have been classical. All right, let's go on. Just a few more left. This is our last question. And what I've done is taken my data and put it in order. We're going to need this. This is a 3-step problem. First, we're asked to find the mean, which is x bar. And we have to add these all up. So take a moment, give that a shot. Well, this is 56. How many items of data do we have? 6. 6 goes into 56 9 times. Now, what would the median be? Again, that is the middle number. Well, that would be taking these two, adding them together and getting 19 divided by 2. That would be 9.5 as your median. Remember, if they're even, you take the middle two. If they're odd number, you just take the middle one after you put them in numerical order. Now, is there a mode? Is there an item that's used more than once? And the answer is no. So the last question would be no mode. Now, if you had something like this, 3, 3, 3, 10, 10, 10, you could figure out the mean of this. This is a 10, not a 19. Looks like a 19. Let's straighten that out a little bit. But is there a mode here? Is there one item used more than another? That's what a mode is. An item that's used greater than the other. And the answer is no. There is no mode here. So students often think, well, yeah, this is used 3 times, this is used 3 times, so there's bimodal. No, there is no mode. Now, if we added here a 15, then this would be bimodal. But there is no 15 in that suggestive example that I gave here. Okay, well, this will wrap us up. It ran a little long, but again, you have 2 hours for your final exam. Time to look over your answers carefully, study, recall, prepare, review, and good luck to all. Looks like simple probability. What is